this video, I talk you through how to use conductivity versus volume of titrant data to make an estimation of the equivalence point. We see in front of us here an Excel spreadsheet that includes the volume of the titrant and the conductivity measurements in microsiemen per centimeter. We are going to make a scattered plot of this data. So let's start there. I'm going to select all the data at this stage and then insert scatter plot. So here we have our initial graph. Now note, for the lab report, you will need to prepare a graph that will look something like this. Of course, you will need to do the proper formatting, which is described in a different video and also in your lab manual. So you'll need to include titles for each of your axes. So the y-axis here, the conductivity in microsiemen per centimeter. The x-axis, the volume of titrant. You'll need to remove the chart title here. You'll need to remove these grid lines. You'll need to remove the border. So in other words, format your graph appropriately. Once the graph is formatted appropriately, cut and paste that into Word and include a figure title. So that will be one thing that you'll need to do once for one sample graph. One of the things that you may want to add in terms of this sort of data is to include some lines that are actually drawn, just to give a sense that there are two distinct trend lines. So for instance, what I mean by that is insert here, and then I'm looking for shapes, and then here's line. So I'm going to draw a line, for instance, something like this, and then I'm going to draw another line. So insert shape and a line as such. And these are just estimations of slopes of lines. And it's more for a visual effect to show that we're looking for some sort of intersection between these two lines. And that point of intersection corresponds to the volume of titrant that's required to achieve the equivalence point. So that'll be one graph that you need to include. However, you will be analyzing 3 different titrations, and for each of those 3 different titrations, you'll need to prepare a different graph where we will be including the trend lines. Here is the easiest approach to produce such a graph. This will work both for Office 365 version of Excel as well as the desktop version. I'm going to start by taking this data and copying it so that I can change it a bit to make this new graph. So I'm going to start with the volume and conductivity and scroll down. So select all that data. In this case, I'm right-clicking, copy, and now I'm going to scroll down further in my Excel page, and I'll paste this data. So there we go. Now, the idea is that I want 2 separate trend lines that corresponding to the 2 different linear portions of my graph. I notice in the upper graph here that essentially the first trend line starts at about 1-2 mils and then goes to about 11 mils. So somewhere between the 2 mils and the 11 mils. Whereas the next line starts at around 12 mils and goes to 20 mils. Let us transform the data down here then. And I'll do that by starting at the 11 mils here, actually at the 12 mils. And I'm going to take this data and just move it over a column. So cut and paste. And then I'm going to essentially plot this data, including these 2 columns. So this will make 2 series of data, but I'm going to start at the 2 mil mark. So there, because that's where the first linear section begins. So now I select all of this data. I now insert my scatter plot. There we go. And sure enough, I have 2 sets of data, one corresponding to series 1, which is our first linear section, and then another corresponding to series 2, which is our next section. Now, be sure to understand that you'll still need to format this graph according to the normal formatting scheme that's described in your lab manual and also in the accompanying video. But for right now, I just want to show you about putting the trend lines in. So I'm going to select the blue data. In this case, I'm going to right-click, add a trend line, And then specifically, I will display the equation as well as the R value. And I will move this over so that it's closer to the Series 1 data. Now I'll draw a second trend line, and I'll do that by selecting the orange data, right-clicking, add trend line, display equation, and also show the R value. And now I have these two equations for lines, and the idea is that the point of inflection is when these two lines intersect. To find that point of inflection, or that point where the two lines intersect, it's simply a matter of equating these two equations. That is, allow equation 1 to equal equation number 2 and solve for x. Because our volumes in the titration are to 2 decimal places, or 4 sig figs, you should be able to solve for x to 4 significant figures. Again, in terms of your report, you'll need to do this process 3 times, or at least as many times that you did the conductometric titration. But in terms of what you report in your report sheet, I need to see, and I'm just going to close this window right here, or we need to see, this graph properly formatted and one copy of this graph properly formatted. If you also did the calculation for 2 other conductometric titrations, you need to do the calculations, but we do not need to see those graphs. I hope this video has helped you see how to analyze the data using a conductometric titration to come up with this point of inflection, which essentially represents the endpoint of our titration.